Hello students, let us continue with chapter 5, Introduction to Euclid's Geometry. We will be taking a look at non-Euclidean geometry. But before getting into details of non-Euclidean geometry, let us see why in the first place it came into existence. Now we know that Euclidean came up with many axioms, postulates and theorems. So for the initial first 28 theorems in the book 13 Elements, he didn't really require the fifth postulate to prove it. Most of the mathematicians as well as Euclidean, they were very sure that the fifth postulate is a theorem and it could be proved by using any of the four postulates before the fifth one. However, so many efforts that they had taken to prove the fifth postulate, they were all in vain. So this in an attempt to prove the fifth postulate, there were many geometries that came into existence, and one of them is known as non-Euclidean geometry, which actually sums up all the geometries that came into existence because the fifth postulate could not be proved. So that is why it is known as the landmark in the history of thought, because if you see that the geometry of the universe that we live in is not actually Euclidean, it is actually known as spherical geometry, because if you notice a sphere, a globe is nothing but a sphere. So our universe will also be related to spherical geometry. So what you need to know about spherical geometry, two very important points is that the lines are not straight. If you see, in fact, this is Earth, right? I am considering this as Earth. So let's say now you are located in India. India will be somewhere over here, anywhere here or here. So let's say I am saying India is located over here. But in real, if you see, you are living on a flat land. So India, it can be like really huge. Let's say it is occupying this section of the board, correct? And connected to India we have, let's say, Pakistan. So let's say Pakistan is also here somewhere, correct? But there are, so let's say this is India, this is Pakistan, there is another country. So when you connect all these surfaces, what you are getting, although they may look straight, they are a part of the entire sphere, which is why the lines, they look straight but they are not really straight, they are actually curves. So if there are countries on this side also, the sphere is a three-dimensional surface, right? So suppose it's like this. So if I am drawing a line, it's going to be something like this. So although it may look straight, these sections, for example, they may look straight, but when you join these together, they are curves. Similarly, they are part of great circles. As you can see, this entire thing is a great circle. Our Earth is a great circle, and the different sections are a part of this great circle. Not really circle, you can say a sphere. Okay. Now, so let's get back to Euclidean geometry and try to understand how it fails. So why Euclidean geometry fails? Let's say this is the globe, I have my north pole and I have my south pole, and this is my equator, correct? And we have different lines, latitudes and longitudes, right? We know that they meet the equator at right angles. So this angle is a right angle, this angle is a right angle, every angle is a right angle. Now as per Euclidean geometry, the lines are straight. But if you see, if you are joining the north pole and south pole, it will look like the line, when you are drawing it, it will look like the line is straight, but it is actually a curve. So one reason why Euclidean geometry fails. The other one is the fifth postulate, which says that if the sum of measure of angles on two sides is, I am just shifting this right angle to here, like the position, you can just keep it like this also. So if the sum of measure of angles on the same side is exactly equal to 180 degrees, which is two right angles, then the lines won't meet. But if you notice these two lines here, the sum of measure of interior angles is 180 degrees, that is two right angles. However, these two lines here specifically, they are meeting on the north pole. So again, another reason why Euclidean geometry fails and the rise of non-Euclidean geometry. Now based on this, let us solve an example. Consider the following statement, there exists a pair of straight lines that are everywhere equidistant from one another. In this statement, a direct consequence of Euclid's fifth fifth postulate. So let us take into consideration Playfair's axiom, which is a direct consequence of Euclid's fifth postulate. Now what does Playfair axiom mention? If you have a straight line L and there is a point P not lying on L, then there is a unique line that passes through P and is parallel to L. So I will say M is my straight line that is passing through P and parallel to L. Now if you notice, if I take any point over here or here or here or here, it's going to be at the same distance from L. So if suppose this distance is 5 units from here to here, this distance is also 5, this is 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 5 and this is 5 and so on. So every point is on line M is equidistant to line L. Therefore, we can say that this statement is a direct consequence of Euclid's fifth postulate because we have proved this using Playfair's axiom, which is a direct consequence of Euclid's fifth postulate. So let's write down the solution. According to Playfair's axiom, for a straight line L and a point not lying on L, there exists a unique line L, unique line M passing through P and parallel to L. Also, Playfair's axiom, I am just writing PFA, do not write PFA, write Playfair axioms. Playfair axiom is a direct consequence of Euclid's fifth postulate. We have learned this just a while ago, fifth postulate. So now there exists a pair of straight lines that are everywhere equidistant from one another. So every point on M is equidistant from the points on L. The perpendicular lines, very important word, perpendicular lines. So every point, every line drawn, every line which is perpendicular from a point on line L, which is perpendicular from a point on line M to line L, is equidistant to the lines, as compared to other perpendicular lines drawn from M to L or from line M to line L. Hence, this statement is a direct consequence of Euclid's fifth postulate. So, hence, the given statement is a direct consequence of Euclid's postulate. So with this, we wind up with the explanation of this chapter. We'll take a look at exercise 5.2 in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.